Hi, my name is Brent Janorske, and I'm a senior solutions engineer with Couchbase. I've been with Couchbase now for about 2.5 years, and I'm here to talk with you today about the SDKs that we offer to connect with Couchbase Server on premise, as well as Couchbase in the cloud or Couchbase fully managed, our Capella database as a service offering. So regardless of the way you've deployed Couchbase, we offer an SDK for most of the popular languages today, programming languages, that is. So this doesn't force your development shop to learn a new language that they aren't necessarily comfortable with. These SDKs are topology-aware smart client software kits. By topology aware, remember that Couchbase is a distributed database that's running on multiple server instances, and we also offer several different services. And you, as the application developer, do not want to have to keep track of which node you need to connect to for your data or which node is running the service you need, be it the SQL capability for JSON or the full text search capability, for example. The SDK abstracts all of this complexity for you. You just write the application to submit the query for your data, and the SDK takes care of all the complexity. Now, in addition, we offer a REST management API for Couchbase Server or Capella, our database as a service offering. This API provides the ability for you to programmatically check on your cluster's health and monitor specific cluster information, that type of thing. So we're going to focus mainly on the SDKs now in this brief presentation. Again, we provide official support for all of the languages shown here, as well as community support for Rust. The bulk of our customers, I'd say today, are certainly on Java and .NET due to the maturity and popularity of those languages. But our goal, as I mentioned, is to not force your development shop to shift off of the language they know best and are most efficient with. So we do provide an SDK for each of these. Now, regardless of the language that you choose to develop in, the following are common entities found in all of them. So first, a single cluster can have up to 30 buckets. A bucket, as you may know, is analogous to the term database in the relational world. At the bucket level, you can set certain attributes that will be broad, such as memory allocations, as well as attributes that will apply to all of the collections and documents, such as ejection policy, should a document need to be ejected from RAM to make room for another, or what the time to live should be for all documents, etc. You can access a bucket object after you have bootstrapped a connection to a cluster object in your code. Within a bucket, your administrator could set up to 100 scopes in that bucket. A scope is just a grouping of collections, which is where your documents containing your data are physically stored. You can have 1,000 collections within a scope. And by the way, these numbers, 100 and 1,000, these are the maximum tested. They can probably be exceeded. From a relational standpoint, a bucket, as I mentioned, is analogous to a database. A collection is a table, and each document represents a row in a table. A scope is simply a grouping of collections, kind of like a schema is a grouping of tables in the relational world. So within the code samples that are available in our documentation, you'll see instructions referencing bucket objects and collection objects and so forth. So this slide is intended to kind of clarify some of this. You'll see an instruction, for example, to connect to the cluster, which we call bootstrapping to the cluster. And then once you have that connection, you can access a bucket object, and within that, a specific collection object, and so forth. So this isn't intended to teach you how to build an application running against Couchbase, just to introduce you to the concepts of how it works. So here's an architectural diagram, if you will, of how all of it works, and I can speak to this for a moment. At the top, you have your application code in blue, and below that, the Couchbase SDK for that programming language. There's a separate library injected into this diagram to depict that it's available should you need ACID transaction support. We chose to implement that as a separate library. And that allows you to do all or nothing ACID type updates to several documents at the same time. But the SDK itself has the ability to access a document from a Couchbase cluster via specification of a unique key, or you can insert or upsert a document while supplying that unique key. Those are key value operations. The SDK also provides the ability to issue SQL++ queries and also full text search queries, and also queries running against the analytics service, should you be using that. So look down below, there's your Couchbase cluster. There you can see that there are multiple instances or nodes running the Couchbase services. Now in this diagram, each node is running the data, query, index, search, and analytics services. We don't suggest you run all those services on every node like that, but it's fine for this diagram. So you're coding this application in blue. Do you really want the burden to know which instance to connect directly to that has your data? Of course you do not. So as I mentioned earlier, that the SDK is topology aware. It knows the topology of the cluster. That learning takes part actually as part of that initial connection process where an upload of the topology map to the SDK takes place behind the scenes. Now, from that point forward, the SDK does all this work for you to determine where to find your document, where to store your document, should you be doing a write. All this complexity is abstracted from the application and taken care of by the SDK. This is great. You don't have to worry about coding for which server or instance to connect to that's running the service you need either. And guess what? If your topology changes over time, let's say a server fails over or you've added a new one in order to scale out, that topology map that I mentioned gets updated in each connected client, which is so awesome and elegant. I hope you enjoyed this presentation. Thank you for watching.